Hi, I'm Peter Capone, CEO of Crystalspace, company based in Brno in Czech Republic. 2 years ago, we had this vision that companies like ours, that countries from Central and Eastern Europe like Czech Republic or other countries from Europe will be able to build a mission to the moon. Now it's reality. In partnership with European Space Agency, our consortium of great partners and amazing scientists from Europe, we have created it. Project is called LUGO, Lunar Geology Orbiter, and it's about science and exploration. Against all the odds, we made it. We are going to the moon, Europe is going, watch it.
Hi, I'm Petr Brož, the principal investigator of the LUGO. I'm working as a planetary scientist at the Institute of Geophysics of the Czech Academy of Sciences. At Project LUGO, we are aiming to better characterize the thermal evolution of the moon. Why we would like to do so? Because we don't really understand when the volcanism on the surface of the moon actually ended. We would like to study enigmatic volcanic features which are named irregular patches, and these are exactly the features on the surface of the moon which can give us the answer. At the same time, we would like to support the future human exploration of the moon. So how we are going to do that? By using 4 different scientific instruments. The first one we have is a ground penetration radar, or the GPR. This is the instrument which is enabling us to see in the subsurface of the moon. We would be able to use this instrument to characterize the volcanic rocks which are forming the irregular patches. We would be able to find out if these features are formed by compact basaltic rocks or by lava flows. Why this is important? Because these are the 2 different end scenarios which are explaining how these features have been formed and therefore how old they are. Our second payload would be a suite of narrow angle cameras. Why we would like to use them? Because we would like to see actually what is on the surface of irregular patches. At the same time, we can use these images to generate high-resolution digital elevation models, and therefore we would be able to get a really nice topography. The narrow-angle cameras would be also used to better characterize and to better study the skylights, which are actually the entrances into the lava tubes. The third instrument would be a hyperspectral camera, which would enable us to say something about the composition, or better to say, about the maturity of the regolith. Why we would like to do so? Because we can use this information to actually reveal the age of the regolith, and therefore we would be able to say how old the irregular patches have to be. Our final payload is a LiDAR, which is a laser altimeter. This instrument would help us to make a really nice topographic profiles of the areas of our interest, and therefore we would be able to map the topography of irregular patches.
Hi, I'm Petr Boháček. I'm mission architect of LUGO. Project LUGO is envisioned to participate in humanity's return to the moon. On the moon, constant radiation and meteorite impacts, as well as dramatic temperature changes, make it hard for humans to survive. Lava tubes can offer shelter and constant temperatures for humans to stay there permanently. This is the next steps for humanity in space.
As you can see, here at Crystalspace, we are ready. We are ready to gather the data that will change the current scientific thinking about the evolution of planetary bodies.